and we have extend, which, and I'm going to skip over this because I've never found a use for this information. Okay, master file table entries 12 through 15 are marked as in use but are empty. They're reserved for growth of the master file table. 16 through 23 are unused. And this is kind of a nice piece of information that shows the similarity between the parts of the FAT and the system files under NTFS. And to me, this isn't exactly correct, because this says this is from the National White Collar Crime Center. Because actually, the root directory here is not akin to this. The root directory here is actually more akin to the master file table up here, because this holds the metadata about each file. And we see here that the FATs, the file allocation tables, are similar to the single bitmap under here. The boot record here is similar to boot file system here, and of course the FAT does double duty because it indicates not only which clusters are being used and which are not, but it also indicates the bad clusters. So you see that the NTFS has a much greater complexity than the FAT file system, but also it's a lot more fault tolerant as well. Okay, this is what each master file table record is going to be 1024 bytes. If we flip back over here to the master file table entries under X-Ways, you can see this goes from here at offset 0 all the way down to 1023, indicating that this is a single master file table entry, as is this. Now, interestingly, the file record size for NT 3.51 was actually 4096 bytes, and they've actually able to reduce it to 1024 bytes, which saves about 4 times as much space under NT 4 2000 and XP than under the original NT operating system. So at the beginning of each master file table record, you have the file record header, and then you have the attributes associated with the file. And so, if for those of you who know about object-oriented programming and object-oriented design, if we think of something called object attribute values, or if you've taken any course in expert systems of or artificial intelligence, you have an object, and this object has attributes, and each attribute has a value. It's called an OAV. And so the object here would be the file, and then you'd have the various attributes associated with the file, and then each attribute would have a value. So you would have, for instance, the attribute name. You would have a short name, you would have a long name, you would have a modified time, you would have an access time, and you would have a created time. And there's also one other date timestamp associated with NTFS, and that is the MFT written time, which means that the last time that the master file table record for this file was changed. So essentially you have 4 different date timestamps for each file under an NTFS. Okay, the type codes. I mentioned before that each attribute has particular type codes, and of course this indicates this is in hex. So you have the standard information here, the attribute list, the file names, the object ID, the security descriptor and volume name, and so on. Notice here at 8 we have our data and all the other information associated with this, and we'll look at these a little more closely later on. What you're going to find here that's very interesting is the fact that, let's go back here. Notice that, remember, hex 80 was an attribute data. The master file table record can actually hold the data associated with the file, that is the file's contents. So if a file is small enough, you can actually find the contents of the file within the master file table record, and we'll see that a little later on. Okay, now looking at the attribute information, we have the first attribute, which is standard information, which is general file information on the creation, modified, and access date and times. If you recall from Linux, and a lot of what we did in the first version of this course, when we worked with Linux, we had a change time, which is slightly different from created time. If you recall, when we were talking about NTFS in the previous course, the created time is the time that a file is created on a volume. And of course, modified and access times are the same as we discussed previously. There's also, within this, we have the typical DOS attributes, whether something is read-only, whether it's archived, hidden, and so on. And it includes a hard link count. Whoops, sorry about that. And as of NTFS3X, we also had information for the owner ID and the security ID, which is, we'll see information on how users are tracked in the operating system. Okay, the attribute list lists all the attributes of the file and their master file table record location, and that's only used if more than one master file table entry is required, and that is rarely needed. I can't think I've ever seen that being used. And of course, we have the file name. And files can have more than one file name attribute. They can have a short file name, as we know, and of course they can also have a long file name. And so the file name attribute contains the file name, a reference to the parent directory, MFT base record, and then dates, times, file size, and flags, and so on. All this information will remain resident. That's a term that we will use quite frequently talking about NTFS, resident and non-resident. If information is resident, that means that the information is actually contained within the master file table. And so, getting back to our discussion of the capability of a master file table record containing the entire contents of a file, that means that if a file is small enough, it can actually be resident in the master file table record entry. The object ID stores the global unique identifier assigned to a file or directory, and it's used for distributing link tracking, object linking, and embedding. The security descriptors is used in NT3X and 4, and it stores access control lists, which we've already talked about previously. And it is not used in Windows 2000 and XP. And most of you who are going to be doing this for a living are probably going to be running into, or more likely to run into Windows 2000 and XP than NT or 4.0. But if you get in larger organizations, don't be surprised if you find some of these boxes still running, these operating systems. We have volume name and volume information is used only in the volume metadata file. And the volume information indicates which version of NTFS it is, whether it's 1.23 or 3.1, and the state of the volume. And the state of the volume was what? Indicates whether it was dirty or not, or clean. And finally, we get to attribute hex 80, which contains the file's data. And what this is called is a default unnamed data stream, and it's present for all files. And so the reason this is called unnamed data stream is because there's also something called alternate data streams or named data streams, which means that a file can have multiple data streams associated with it, and we'll see later on how that's used to actually hide information on a hard drive. And so any of a file's normal contents will be in this default unnamed data stream. And as I indicated before, if the data is small enough, the data can be contained entirely within the MFT record. That is, the information is resident. However, if large, the data will be stored in the clusters. That is, it will be stored non-resident elsewhere in the file system. And what we'll see is that the clusters that comprise these files will be contained in something called run lists. And a run list is a list of clusters that are associated with the data file, wherever that file is residing on the hard drive. Okay, and this is other stuff that I've never used before, or I don't know how it would be useful for forensics purposes. And we've talked about bitmap, the sequence of bits, each of which represents the status of an entity. Let's keep on going down. Yeah, I've never seen this being of any use. This is for compatibility with HPFS. Never seen that being used. Okay, I've never seen this being used, but this is important that we talk about this. Windows has something resident called the encrypting file system, which allows you to automatically encrypt volumes on your hard drive, and this is what the log utility string useful for holding information about EFS. Okay, so let's look at what exactly happens when we store a file under NTFS. The first thing is the log file metadata file is updated. Now, this is interesting because, as I indicated before, even before a write operation takes place or a copy operation, is that information on that transaction is written to the log file. And the reason is if the plug is pulled, if your computer crashes, then the operating system can go back and read within the log file where that left off and see what transactions were not completed. And if the transactions were not completed, I can actually roll back the transaction to its previous state. After that, a master file table record is created for the file, and the standard information is written, including dates, times, the size of the file, the security ID, and so on. And the file name is written, so what we're doing is we're just going linearly throughout the master file table record that's been created. Remember, this is 1024 bytes. If the file has a long file name, its short file name is also written as well. It's a long file name and the short file name. Following that is the default unnamed data stream. And recall that if it's small enough, it can be stored in the master file table. And interesting, a file can have all of its attributes residence if it's small enough. And this is what saves so much information over the FAT file system, is that a lot of the information can actually be within the master file table record, the entire file contents as well as all of its attributes. Okay, if the data attribute of a file is non-resident, that means that its contents are too large to be enclosed within the master file table record entry. The attributes header is always resident, and the attributes data stream, remember that's the unnamed data stream, is stored in a volume in one or more continuous clusters called runs. And the run lists are stored in the data attribute in the file record. So instead of containing the actual data, the run list, which is the list of clusters that comprise the file, are contained in the data area. Okay, and this is one of the tools that we'll use to look at Linux later on, and this is called, this is an early version of Autopsy. So what this is actually doing is it's showing some information about a master file, a file on an NTFS volume. Shows the MD5 hash, the file type. Details is the master file table entry record, which is 3944. And over here is going to be the run list. Notice this says the standard information times, which is going to be which attribute. It's going to be the first one. Notice it says the created. Notice it has 4 entries right here. The created time, the modified time, the access time, and notice this third one, the master file table modified time. And this kind of gets clumsy using both of these terms, modified. And so what you'll see is in some of the forensic suites, this will be termed written. So you have a created, modified, access, and written time. And when it says written, it's actually referring to the last time their master file table was written to. The file name times associated with it. Here we have the attributes, standard information, the file name, whether it's resident or not, resident size 72 bytes, And okay, there should be one more there. Here we go. Okay, resident data. This is an actual master file table entry right here, although you can't really see it up here. But notice here that this is my previous place of employment, but notice my entire signature was small enough to be located resident within the master file table entry for this file. And that's quite a bit of information. Okay, now that was a resident file. Now here's a non-resident data file that's 212K. It's the NT loader file. The master file table entry, let me see down here. It's got the DOS modes. It's a file that's read-only and it's hidden. It's got the size of the file, the standard information that we're familiar with right here. And here's what I was trying to get to, is the data. Is that this is the run lists. And so this information is contained within the data area, as you see here, of the file. And so essentially what this is showing is these are the clusters that are comprising the NT loader file. And I'm not sure if this is every one though, but notice I'm pretty sure this is contiguous, which means that this file is not fragmented. Yeah. Okay, storing files in NTFS. There's two types of cluster numbers. There's a logical cluster, which are numbered sequentially from the beginning of the partition, and they start with 0. And you have virtual clusters. Okay, and the virtual cluster numbers are numbered sequentially from the beginning of the file. So the VCNs start with 0. Let's go back here. So this is virtual cluster number 0, 1, 2, 3, 4, 5. And the logical cluster number, of course, it doesn't say on here, I don't believe. No, it doesn't, but that would be starting from the, oh, well, I guess this would be it here. This is logical cluster number 117602, logical cluster number 117603, but then the virtual cluster number would be 0, 1, 2, 3, 4, and so on. So the run lists associate the VCNs of a file with the logical cluster numbers in a partition. And this is essentially what we saw before, except in an abstract format. This is looking at the logical cluster numbers, the virtual cluster numbers, and the run lists. And so if we have a fragmented file right here, the virtual cluster number of this file, notice that it's fragmented, so it's in 3 pieces right here. The virtual cluster number of the file starts with 0, 1, 2, 3, 4, 5, 6, up to 11. And the logical cluster numbers indicate that this file starts at logical cluster number 78 from the beginning of the partition. And then within the data area, we see that it's got the starting cluster number and the starting logical cluster numbers associated with it. So 0, 78, 4, 84, and 7, 91, and then the number of clusters that are within that run. Okay, storing files in NTFS. Once that file is written, the bitmap metadata file is updated to indicate which files are, which clusters are in use. And so recall, this is a byte right here. And so let's go back here and see if we can find that. See, let's go back to bitmap. You see right here. So essentially this right here, since that's a single character, that's going to be 8 bytes. Let's go back here. That's that right there. And so that indicates that those 8 clusters are in use. Finally, the master file table's bitmap attribute is updated, and that's how the file is written. Now, when deleting NTFS files under NT 2000, and we're actually going to get much more in depth into this and show exactly how a file is deleted under NTFS. And here we see, I can't remember why I actually did this right here. Let's see if we look down here. Oh, within the recycler. Okay. And so here what we've done is if you recall, when we were looking at those two files, here's the names of the files, abcdefgh.txt, and then the one that was much longer. Those are the two files. We were looking at their entries. Under the recycler, notice that this has got two different security IDs that are tracking different users right in here. 11103 and 11004. And so within the recycler, each user will actually have their own SID named folder. And so when a particular user deletes a file by a Windows compliant program, it will be placed within this file. And the reason they do that is for the ability to recover that file should recovery be required. And then here we see in the recycler, here we see a folder for this user. So this folder has been deleted, and you have these 4 folders right here, files. Two of them have a link extension, two of them have a text extension. And I'll quickly go over this, but we'll get into this much later. But notice this D indicates that the file was deleted. The C indicates the volume from which the file was deleted. And then each of these numbers is the sequence in which the file was deleted. So that one was deleted first, this one second, this directory third, fourth, and then fifth. The info.2 file we'll talk about much more later, and that holds the information on the original location of these files. So that when you go in and you say recover this file, that the operating system reads the contents of the info.2 file and can actually recover that file to its original location. So under NTFS, when a file is deleted by a non-compliant program or via the command line, it's handled similar to the way it occurs in the FAT. The associated clusters are marked as free and available for data updates. The bitmap file attribute of the MFT is updated to reflect the deletion of the file. The file attribute record for the file in the master file table is marked as available, and all that file attribute record is a 0 or a 1. And so if it's 0, it means that that's available, and 1 means that it's being used. Any linking pointers and virtual file numbers or logical cluster numbers are removed. So when the list of links are deleted, any reference back to the links is lost. If that makes any sense. Okay, and so that ends our discussion of NTFS. What you should do